I could describe myself as being a software engineer. I come from an engineering background and a degree, but at the same time I've been developing for many years since a very early age, and I've put my hands on all the technologies that were around, except Java. That would include C, C++, then PHP, unfortunately, then Python and other scripting languages. I've come to appreciate Python a lot for what it can offer, and working at least for the past 10 years, mostly with Python. But at the same time, just since I had all this experience and all these years have passed, I've come to wonder about questions about the whys of the code, about software quality, about delivering the software and the engineering behind making your software resilient, robust, and all that. It's not just about typing code on a keyboard. So in an attempt of quality, I had to touch on the subjects of testing. And I have to mention that I've been a proponent of open source. I've even put a couple of lines on Linux kernel. Been working with open source communities for many years, and I like to hand over tools to the community so that they can work and improve them, and also get the power of the community back. So starting about a testing talk, I should put a big disclaimer that I'm not a fan of testing. Testing was not my original subject, and I don't believe that testing can solve all your problems. So testing is a way to indicate, to trace problems, to find patterns, but it's not the way to eliminate them, or not the way to be 100% sure that your software doesn't have any issues. It's just a way to narrow down on some of them or give some partial confidence that your software is okay. And it very much depends on testing itself and the quality of the testing to provide useful results. So like just any testing will not do. Just writing unit tests for every single line of your code may still allow major bugs to be there and blow up in production, as they usually do. So the other thing of the day is web UIs, web applications. They're not just simple pages anymore. They're very rich applications. You do pretty much everything with your browser, and like you use a lot of code inside the browser, inside these languages. So in the old days, just because I'm a little older, we used to write just simple HTML that was just a declarative data page which the other customers would read. Now it's a full application in JS and frameworks and browser things, like can do everything, which makes it harder to assert. And since we are using very advanced frameworks like all these Angular, React, Views, MJ.js, you name it, the complexity of what you deliver to the browser, what you show to the customer, to the user of your page, is just exploded. It's not something that you can have like a simple test on. And still, your web UI is your front face, is the thing that all of your customer, all of your user will see. So if there's something wrong with it, it will be immediately apparent to your user. In the back end, you may have major bugs, you may have very bad code, and if it still delivers the API results, it may still work and may still be acceptable. But in the UI, if something is not okay, you have a very high chance that the users will notice, will be frustrated, will comment on you and so on. So, and still, the UIs are so complex that they interact. You know, you hover the mouse over something and then the whole structure of something changes. You tilt your screen, and with a reactive design, the whole thing rearranges itself just to fit your screen aspect and so on. So it's not something static that you can immediately test. Jump to the other side. What has Python to do with that? Since the UIs are in JS, mostly are a browser technology and so on. Python, to my opinion, is the best language you can use for testing for a number of reasons. First of all, if you're writing tests, you're writing scripts. You want them to remain scripts. You don't want them to be compiled as binaries. You don't want to distribute them, install them, have an engineering life cycle around running your tests. You just want them to run. So you want a language that is very close to scripting and yet be powerful enough to write things. You want your language to be simple enough to get rid of the syntactic sugar and other elements of the language so that the tests are written ideally in a pseudo language, near human language, because you want to be able to read your tests and have the confidence that the tests are doing what they mean. So a language that is simple enough is the best choice to write your tests in. And frankly, Python is one of the best languages to write backends in. You can write business logic, you can write frameworks and things like that in the backend. So it makes sense to use some of the backend's preferable languages also to do all the other tasks around your projects. Unfortunately, you cannot use Python itself in the browser so far, but since you cannot use it directly inside the browser, you can still use it for your tests. And it's a very nice language, very easy. Also, the benefit is that the testers should not be advanced programmers. You should lower the bar and allow more junior people or more people of other areas to jump into testing and help you with that. So an easy language helps there. And also, through my project and other tools, you'll find that Python is very modular, very easy to extend. It's very easy to test other things apart from the browser itself because there's libraries for everything. So it helps in that way. So if you were to start looking around of how to do tests with Python and a browser, you'll come up with this stack of using the Selenium, which is pretty much standard, and there is several tools on the high end, like high level of that stack, and one of the best options is Behave because it offers behave-driven development and behave-driven approach to testing. And behave-driven approach is that you explain in very simple terms, in very simple sentences, what are you trying to test. So I want to enter my page, log in perhaps, click on something, enter that form, and see that the page accepts it or reacts to what I have entered. So this is your script. Then Behave expands that to a set of steps that you need to perform in order to implement the steps. So it's one of the best choices. And then Selenium, on the low end of that stack, it's perhaps the only choice because it is standard, it defined its own standard, and now it's supported across all languages and all frameworks like that. So it uses a standard like that Selenium had introduced. It's called WebDriver, is the way to instruct and command the browser through an external API and have your browser follow a script. But the problem with that was that the kind of language, the kind of Python API that you would write your tests is not, your steps is not very easy. So what I have put here is, sorry, let me get the mouse here. No, okay. So this is an example taken from some other project that tells you how to use Selenium and Behave. So Behave requires that you define your steps somehow and expand the English sentence of when I enter something into some Python steps. And the Python steps would look like that. You have to get to the driver API, find the element that you need to interact with, and perform some actions. But this is one of the cleanest cases you can see around. So real world is not like that, it's much worse. The second definition down here is a more actual one. So you have to find an element that doesn't have an ID, and usually the IDs in your web page don't exist, or they're not unique, or they're not constant. And you have to traverse all the DOM tree to find something. And this becomes getting hairy. And as your web application gets more complex than just a simple login page, then this thing doesn't scale. So you'll find yourself typing a lot of XPaths, a lot of Python commands to get things done. And in real-world applications, in business that we want to get things done fast or write many variants of the same test, this thing is starting taking too much time. So, and of course, if you're putting this XPath here, if your DOM is dynamic, it's very, very likely to break. So, there's one more div, one less div, there's some other element that would match the same XPath, and then all your step definition is blown up. And that's not a problem of Python only, that's a problem of all languages that use Selenium, all frameworks that try to resolve elements through XPaths or whatever tools. Like the XPath is the most advanced tool that is provided by the browser to do that thing. So most frameworks come down to this limitation. So I went on and wrote some utility middleware to address these problems. So the basic idea is that we abstract the DOM, what we have in the browser, into components, into much simpler objects that expose their interactions as object-oriented methods. Then these interactions, like typing the keys, or clicking a button, or having the drop-down, or dragging things over, are just simple methods. And we try to make them as simple as possible. Then we can even nest the components so that if you have like a date picker element, you can reuse it across the testing of your whole application. You don't need to repeat copy-paste the code everywhere. So then this also gives an advantage. You can split the effort of matching your DOM, matching your page, from the effort of writing the steps and writing the procedural logic that says, I need to go there, click that, see the next form, fill in the next form with these field values, and so on. So it's one different thing if you're filling the values, and the other thing of how to click on things to enter the values. Because sometimes entering the values is not just entering text fields, it's more advanced than that. There is the other concept of recursive abstraction. So once you have abstracted the components, you could abstract more complex things like the forms themselves and say, okay, I want a step that in one line, it will fill all the required details for that. And then I want a step that will go through so many pages and enter all details and make them ready for my next step of the test. So you can abstract and build on abstraction and come to a very high level that you will only be writing what you want to test. And at the same time, the framework itself will have such infrastructure that it will catch any inconsistencies while going through all this abstraction. So if something doesn't work through that cycle, it will flash it. It will tell you that, okay, I stopped there because something is not right here. And also, there is a couple of lines that you need to configure your browser, bring it to the settings you want to match your site, and so on. So let's put them away and put them in a utility function so that you don't need to care. You write a YAML file, a configuration file that will show you, and That's all you need to get your site working. So the architecture is from top to bottom that you have a web page in the browser, and the browser thinks in DOM. So we're not doing pixel-based testing. We're not asserting the image of your page. We're asserting the structure of your DOM. This is a fundamental thing in this kind of testing. So you're ascending on the DOM, and you can map the DOM through the Selenium API, so that it can find all these things as objects. But then you match the DOM with HTML. You don't match it with procedural code. You match it with HTML that closely resembles your target. And that's a very big advantage, because you can immediately tell from your HTML what it's trying to match. So a div will match a div. A P will match a P. But then you want to read the content of that P, so you make it a variable, an attribute. So you want that div to be an interactable component, so you put that and make it a component. And then your Python code has to work with things like that. Sorry, I will point with a mouse, preferably. So it will work with that. So it has objects that correspond to your component. The objects have attributes, and you're playing around with the objects and the attributes that mirror what is over there in the browser on the other side down there. And then your step implementations in Gherkin, in Behave, will be very simple, because you just need to address your components by name, but whatever name you assign to them, and you say, okay, I want this to check this, that the title component, the title attribute of that section component, has this expected string. So it makes it very, very simple. And you can build on that and make it even simpler later. So the implementation details is that you have the HTML-like language. So it's not HTML, it's not getting parsed. You abstract, you write as little as possible and as much as needed to make things work. And of course, because it's parsing and not rendering, you will have repetition elements, optional deep choice elements, and so on. And you have to name the things that are your components. So this is a full segment of something that goes to that pseudo HTML language. And you will notice all the usual HTML elements, but some done in this brown color that are the things that are not HTML. So you just assign a name to that thing. You just take, you have a choice of either this or this component. So it goes like this. You write something that's HTML, and then you decorate it with some more keywords to make it expose the interesting parts of your DOM into something that you can manipulate with your tests. So I will run through things. So you have Python exposes Python objects like dictionaries. So the subcomponents are items in your dictionary. You can do attributes. They're all lazy. They're not parsed one time. They're parsed as you try to access them from your step definitions. And they're written in a way that Behave can use them. So you get to the table of your page, whatever content there, you'd get the rows, and the length is the length of your rows. You have your count. Then you can assert it, and so on. So how to work with Behave manners? You just make an environment. I would recommend to use virtualenv, because that will be your little testing directory where you put everything. Python 2 is still supported and will be supported by the project, because I want it to apply to legacy applications, legacy code, for the time being. You have to install the Behave manners, and it has some dependencies. It will bring Behave 1.2.6, and be careful because 1.2.7, when it's released, it may be backwards incompatible. You will need the Chrome driver, which is a binary that binds the Selenium to your browser. So the Chrome browser is for Chrome. The Chrome drivers for Chrome, there is a Gecko driver for Firefox and IE driver for IE. And you will need some initial files, just this to start with, which is an environment to configure things out, a config YAML where you can put the configuration settings that Behave Manners will use. You will need to build an index of your pages, like what each URL on your application corresponds to. That's the index HTML, and then definitions of the pages, and then your feature files, your testing, as in Behave. I'm just running through that. You will find all this information in the documentation of the project. But then you want to assert, like you're running this HTML, you want to assert that this thing matches your page. Is one of the difficult tasks, always. There is a validator tool, just a utility inside the Behave Manners, that allows you to launch a browser and then start testing your HTML until it matches. So it keeps the browser there. You can like use your mouse, your own like human interaction to bring your application to the page you want to match, to the state you want to match, like perhaps with a drop-down expanded or something. And then you're playing around with the other part of the validator, the validator part of the validator, which goes there, tries to match the DOMs and tell you what it has found, what it has missed. So this separates the matching of the DOM from all the other testing harness. So, and it also has an interactive mode that you can check, like has a Python cell that you can check the object and like do the dot something methods and see how they work. I do have a demo video, and I'm not sure if I will have any time left to show something live. So this is just the things in action. You will see the Behave flow here and the browser there doing what it's supposed to do. Some things are hidden there because they don't scroll into view. So it clicks on the option buttons there and so on. So clicking on option buttons with material is not straightforward. You have to do some tricks there to get it, or an autocomplete. And here it goes, like it has, and actually there's a slow element in that which made it run a little slower than usual, because that would normally end in just 6 seconds. So there is some advanced topics on that, yes. I'm ahead of time already. There's some advanced topics that you can assign through some Python code. You can assign extra methods, extra attributes to your components. So if I go back to the early slide, so you have your remote, the matching DOM, the page elements, and you can say that this is the OK button. This is the payload div, whatever. This is the form. And it would have some standard attributes defined with these brackets. But sometimes you want to expose some more difficult to compute attribute, like you want the value of an autocomplete to come from either there, or a combination of other elements and so on, or you want to find the CSS properties and things like that. So there is a way to amend the Behave Manners things. Wait, you just have to go there. Okay, how to play. So there's a way to amend that and write a little Python code, the minimal Python code that will make these elements have extra attributes or extra abstracted interactions. That's it. So this is explained better in the documentation. And then I'm 20 minutes past, and I've not shown you any Python. Here it is. So the beauty of that is that you don't see the Python. The beauty of that is that you don't need to be an expert in Python to write your tests. You write them in a very simple language, and yet Python does the rest in a way that you don't need to know everything. So you write very minimal Python. You don't see the Python, but Python does all the dirty work of making it work. I can show you a little text or get your questions, or whatever you prefer. So we have like 5 minutes left.
Questions?
You want to see some code or ask questions?
The interactive tool you talked about for testing your expressions.
So, yeah. So this interactive tool has two things. Let me bring that window over. Oh, okay. That's large enough, I get. Oops. So what you do is, no. So you call that tool, which is called run browser, and just launches a browser. It needs to launch its own browser so that this browser is connectable from the other side of the tool. And the browser will sit there. So I'll bring it over just to show you. We have just a browser there. Oh yes, and it can even go to the root of the site that you want to test. So that would be material. Yeah. Our network's okay here. Yeah, it will come up. And then, so I'm still in my cell. You run the validator. And, oops, yeah. So the validator will launch a session that it starts to find the elements of the page. So if I go to components, and I go to the complete one, I think it's the overview or the examples, I don't know. I have to scale it. So, oops. Actually, we're going to run with this one. Where's the mouse? Ah, where's the mouse? Here it is. So you'll see here all the elements just in a very rough cell tree that it tells you all the elements. So there is an example autocomplete opt group, which is there. The title is this one, and the attributes are those. This is just for developers to read back what they have in the remote DOM. So, any other questions?
Panos, thank
Yeah.
you very much. It was a great talk.
Thank you.